In this video, we will be using Booth algorithm to multiply two different numbers where one will be signed, the other will be unsigned. So here we are going to deal with the example of multiplying minus 7 and 4, which results in minus 28. Let us do that now. Here is a Booth's flowchart, and this is going to be common whether the number is a signed number or an unsigned number. So first we have to start and initialize register A to 0, Q minus 1 to 0, and we have to assume that multiplicand to be M, multiplier to be Q, N to be the number of bits. And later we have to check what is in Q0, what is in Q1. Based on the bits available in Q0 and Q1, we have to take decisions. So let us see first Q0 and Q minus 1. If both are either 0, 0 or 1, 1, then we have to just go for arithmetic right shift of contents in A register, Q register and Q minus 1. Then reduce number of bits n by 1 and check whether it is 0 or not. If it is 0, we can stop the iteration or we can continue with the flowchart once again. If it is 0, 1, then we have to add the content of A register and contents in M, store it in A. Or if it is 1, 0, then we have to subtract the contents of M from A register and then store again in A. After these two operations, again we have to go for an arithmetic right shift of A, Q and Q minus 1, reduce n by 1 and check whether it is equal to 0 or not. This procedure is common for all, but based on these variables in the Q0 and Q minus 1 register, that is bits in Q0 and Q minus 1 register, we have to take these three decisions accordingly. So with this as a basic, let us start doing an example. Here, the example that we have considered is to multiply minus 7 with 4, where minus 7 will be the multiplicand, 4 will be the multiplier, which results in minus 28. Another example with a positive multiplicand and a negative multiplier is also been loaded in this channel. The link is given in the description box. So first we'll start with the initializations. As we already seen in the flowchart, A will be equal to 0, 0, 0, 0, Q minus 1 will be 0, M will be the multiplicand, Q the multiplier and N will be the number of bits. And here we know that multiplicand is minus 7, where the binary equivalent is 1, 0, 0, 1 and 4 is a multiplier whose equivalent is 0, 1, 0, 0. Before proceeding into the problem, we'll calculate what M is and as well as minus M, which will be later used in the algorithm. So let us calculate that first. So here we have M, which is equal to minus 7. So this term is equivalent to M and 4 is nothing but Q, which is the multiplier. So right now we need to calculate what M is. M is equal to minus 7. Then what will be minus M, which will be equal to 7? It is easy for us to write the binary equivalent of 7. What is the binary equivalent of 7? 0, 1, 1 and 1. So first let us find 1's complement of 7, which is equal to 1, 0, 0, 0. If you add 1 along with it, we will have the 2's complement. So this will be 1, 0, 0, 1, which is nothing but 2's complement of 7. This value is equivalent to minus 7. Therefore, M will be equal to minus 7, which is equal to 1, 0, 0, 1. And what is minus M? Minus M is nothing but 7, which is equal to 0, 1, 1, 1. So we have calculated both minus M and M as well. Q is already an unsigned number, so it is never an issue. We can proceed as such. So with all these calculations, let us start doing the problem. So what is the first initialization? We have to put A is equal to 0, 0, 0 and 0. What should be the Q? Q is our multiplier, which is nothing but 0, 1, 0, 0. 0, 1, 0, 0. Q minus 1 should be initialized to 0. So these are the first initializations. So let us go to the flowchart. After initialization, what should we do? We have to check what is in Q0 and Q minus 1. Q0 is this bit and here is the Q minus 1 bit. Both are 0 and 0. What happens if it is 0 and 0? We have to just go for an arithmetic right shift of the contents in A register, Q and as well as Q minus 1. Reduce n by 1 and check whether n is equal to 0 or not. Let us do that. So, if both are 0, 0, we have to just go for arithmetic right shift. So, what shall we do now? Take the 0, shift it to Q minus 1. Write the remaining 3 bits as such, 0, 1, 0, and the first bit will be shifted from A. So, I will have 0 here. Write the remaining 3 bits of A as such and retain the first bit here again. So, this becomes the shifted output. Then what you have to do? Reduce n by 1. Now it becomes 3. Is it 0? No. Therefore, we have to continue the algorithm. Now again we have to check these 2 bits. Again it is only 0 and 0. Therefore, go for arithmetic right shift once again. What happens? The 0 will be shifted to Q minus 1. Retain these 3 bits as such. Bring 0 from A because we are shifting. All these bits are shifted by one place. And retain the other 3 zeros here. Just drop down the 0 as a first bit. Okay. So now again it is done. Then what is the next step? Reduce n by 1. N will be now 2. It is not 0 again. Therefore, we are going to continue the algorithm. Now you have to check Q0 and Q minus 1. It is 1, 0 now. Let us go back to the chart. What happens if it is 1, 0? We have to calculate A minus M and store it in A. What we have to do? A equal to A minus M. Let us calculate that first. What is A? A is right now 0, 0, 0, 0. What is minus M? We have calculated already. What is minus M? It is 0, 1, 1, 1. It is 0, 1, 1, 1, which is nothing but your minus M. If we add together, what happens? 1, 1, 1, 0. We are doing A plus of minus M and forcing the value again back to A. So what is a new value calculated? It is 0, 111. Therefore, we replace it in the A register with 0, 111. Q register will be the same, 0001. Q minus 1 will be 0. What you have to do after calculating A equal to A minus M? Again, you have to go for an arithmetic right shift. Okay. So let us shift once again. The Q0 bit right now it will be Q minus 1. Retain the 3 bits as such. Shift 1 from here. So this becomes 1. Retain other 3 bits as such and replace this value again here. So 0011 with 1, 000, Q minus 1 to be 1. It is done. Now what we have to do? Reduce n by 1. Now n is equal to 1. So it is not 0. Therefore we have to proceed with the algorithm. Check Q0 and Q minus 1. It is 0 and 1. What happens if it is 0 and 1? In the flowchart we have seen that it should be A plus M stored back in A. What is A now? A equal to 0, 0, 1, 1. What is M? M we have calculated as 1, 0, 0, 1. So M is equal to 1, 0, 0, 1. If we add these two together, 1 plus 1 will be 0. We will have a carry 1. Again 1 plus 1 will be 0. We will have a carry 1. 1. Again if you add, we will have 1. This should be the new value for A. What is it? It is 1, 1, 0, 0 and 1, 0, 0, 0 and Q minus 1 will be 1 as such. I am just copying Q here and 1 here. So right now A equal to A plus M is done. Again, what you have to do, we have to go for an arithmetic right shift. Let us shift. So Q naught will become Q minus 1 now. Retain the 3 bits as such. Bring 1 bit from A. So therefore this becomes 0. Retain values of A as such. And copy the first bit back to this place. Now what we have to do? Again we have to reduce n by 1. What happens when n minus 1? It will become 0. And we know that in the algorithm, when n is equal to 0, we have to stop the procedure. Therefore, we are freezing here. So what is the final value that we have received? It is 1, 1, 1, 0, 0, 1, 0, 0. This is our final answer. Now we have to check. What was our question? It was to multiply minus 7 with 4, which results in minus 28. It is not directly easy to calculate minus 28. So we can calculate the binary number for 28 first. What is it? It is 0, 0, 0, 1, 1, 1, 0, 0. This is the equivalent of binary number 28. Now let us find 1's complement of 28. What is it? It is 1, 1, 1, 0, 0, 0, 1, 1. Add 1 along with it. So 1 plus 1, 0, carry over 1. Again 1 plus 1, 0, carry over 1, 1, 0, 0, 1, 1, 1. This is nothing but 2's complement of 28. What is 2's complement of 28? Which is nothing but minus 28. This is a value of minus 28, which is 111000100. Do we get that here? 111000100. So this is equivalent to minus 28, which is our expected answer. Minus 7 into 4 equals minus 28. This is what we expect. And here we resulted with same minus 28. So thus we have performed signed multiplication using Booth's algorithm, where we obtained minus 28 just by direct multiplication of the two decimals, and as well as through the Booth algorithm procedure also. Hope the explanation was clear. Here the complete content is being typed for clarifications. I hope the contents of this video was clear. Thank you for watching.